The broadcast is now starting. All attendees are in listen-only mode.
Good morning. My name is James Mancini, and I'm with Netreo. Today we're going to be talking about successfully managing SD-WAN migrations. So first, let's kind of look at where the state of SD-WAN is. SD-WAN is a major force in data networking. When properly considered and installed, SD-WAN can transform the enterprise environment from the legacy structure of MPLS to a next-generation infrastructure that can be managed in real time. This enables next-generation applications and collaboration for both lower cost and better service levels. The migration to SD-WAN has already begun, but we're early in the process. In 2018, only about 30% of WAN refresh initiatives included SD-WAN, but that number is expected to more than double to over 65% in the next 3 years. So what makes this a challenge? As of the second quarter this year, only 30% of the Tier 1 carriers offer their own SD-WAN virtual CPE. And by the end of this year, it's expected to be over 80%. That means the market is being flooded by a lot of new players, as well as established MPLS carriers. But a lot of those don't have much experience and no real track record with SD-WAN and virtual CPE support. So managing the migration and managing your applications through the migration becomes a critical part of the process. So in a traditional device management, network management model, most of the performance data is collected by interrogating the devices directly. So this is the model we're all familiar with. The management system reaches out to the devices using SNMP or WMI or an API, and then those devices return the requested data directly to the management system, which processes and stores the data for alerting, reporting, and analysis. Pretty simple stuff. But in an SD-WAN environment, we add another layer of abstraction, the orchestrator. So the orchestrator is usually a physical or a virtual server that runs software to create and manage the network. Depending on the SD-WAN vendor, this can be hosted on-premise or it can be a cloud-based system, which is becoming more popular. But the infrastructure itself usually consists of a number of virtual CPE devices, which can either be server-based systems or can be embedded systems like remote routers. These devices often expose minimal management data directly, so the management system now has to interrogate most of the critical performance data directly from the orchestrator via an API. So we interrogate the orchestrator's API, it responds with data about those virtual devices, as well as stats for things like bandwidth, traffic usage, QoS policies, all of that type of data. Now, this is a critical point because many SD-WAN vendors today rely on their own cloud management portals nearly exclusively and have lagged behind in API development. Now, that might work for very small organizations, but larger and more agile organizations need centralized command centers, and creating more information silos is problematic. Orchestrators can also send directly to the management system using trap-like mechanisms, but these are very inconsistent between vendors, and setup can be a problem with firewalls. So as we've seen in an SD-WAN, the device-centric collection model migrates most of the telemetry data to API collection from the orchestrator. And for this reason, it's critical to find out which APIs the vendor supports and what data they make available. So after working this hard to get all the enterprise visibility centralized, we don't want to just give it away to migrate to SD-WAN. Relying on a vendor's embedded management portal seems like an easy answer, but it creates an isolated information silo and creates multiple points of administration to create and manage alerts, schedules, performance monitoring, and reports. This also increases the training burden on your staff. Centralized monitoring allows you to quickly determine whether a problem is global in nature, and knowing which alerts are outstanding when a major problem occurs helps to identify the proper support teams to engage to reduce the time required to resolve the problem. While most of the information about the SD-WAN will come from the orchestrator, you will still need some visibility into the CPE devices to make sure you're getting complete telemetry. This is especially important with virtual CPE because oversubscribed virtual hosts will lead to suboptimal performance. So keeping up with the speed of deployment that SD-WAN enables means you need to automate the process of monitoring your infrastructure. OmniCenter has API integrations that automatically discover new resources, as well as advanced network scanning capabilities. This allows OmniCenter to find new sites and deployments and then drive that configuration forward using rules to define things like categories, strategic groups, and templates. And those can control every aspect of monitoring configuration with minimal overhead. So if we can have, when we find a new system online, automatically have it mapped to the right site, the right category, the right strategic groups, have the right polling types applied to it, have all of the alerts and reports and things like anomaly detection all pre-configured in those templates, it drastically reduces the admin burden. And less time spending those systems in monitoring means more time to focus on the important tasks. Gartner estimates that over the next 2 years, the ratio of managed devices to administrators will more than double. So it's critical to embrace this kind of automation as early and as completely as possible. OmniCenter's rule-based automation allows you to push automatically discovered devices into those categories, strategic groups, and sites, and apply all the required templates based on any criteria, including things like device name, location, running processes or services, anything like that. So that means we never miss a configuration step. There's no manual intervention required. So we're removing the labor-intensive element of keeping the monitoring system up to date to make sure that our monitoring can keep in sync as we deploy, new locations or new paths with our SD-WAN environment. You can also have those rules automatically reapplied to devices as they're rediscovered. So the system always stays completely in tune and up to date without any manual intervention at all. With OmniCenter, you can use what we call anomaly detection to find changes in network or application behavior, and you can apply this almost anywhere. So CPU, bandwidth usage, application traffic, even log messages. So if your application suddenly jumps from 10 login failures an hour to 1,000, the last deployment you did may not have gone as smoothly as you expected, but now you have a starting place to troubleshoot. So allowing to detect unusual behavior and not just based on fixed thresholds gives OmniCenter a lot of flexibility in detecting unusual conditions. For example, if an application suddenly starts using a lot less bandwidth than it normally does for this time of day or this day of the week, that might be something that we want to go look into, as opposed to, fixing a static threshold that says alert me when SQL goes over 800 kilobits per second on this line. We can look for just unusual behavior, so you don't necessarily have to pre-program all of those, as we'll automatically be able to generate the baselines based on the historical data we've already collected. So this allows us to look at changes in behavior based on time of day of week, or even hour by hour, and we'll build an automatic 8-week baseline for every metric in the tool. So when you add anomaly detection, if you've got history for it, it'll immediately start working based on that history. And this also allows you to find impacts you might not expect. Like if you migrate to SD-WAN and it causes an increase in CPU load on a critical application server related to a latency change, for example. Finding these kind of things and pulling those important information out of the data is a critical key, and we can automate that using those anomalies. So automating the monitoring also means automating the response. So we can link in vendor APIs like webhooks, so the monitoring system can restart ports, retest applications, even dump real-time diagnostics in response to an issue. We also allow you to control those commands manually through operator intervention. So if you want to add a click to restart remote CPE function directly into the management interface, there's an easy way to do so. And you can do that based on user permission. So only specific administrators or specific authorized command center users have the permissions to do those kind of restarts. However, keep in mind, if you're going to automate response, maintenance windows become critical. Otherwise, a scheduled software upgrade isn't going to go like you expect, because the monitoring system is going to be taking action in the background that you don't expect. One example is we had a customer who was using this to automatically restart services on a server, and when they were trying to upgrade that particular service, they would stop the service, and then the software would complain that they couldn't do the upgrade because the service was running. And it took them a little while to figure out that OmniCenter was in the background restarting that service over and over again every time they stopped it. So creating a maintenance window, either manually or via the web interface or the mobile app, or even via the API call, will prevent that from becoming a problem. One of the key points in making an SD-WAN migration successful is to make the monitoring data visible so that we're not containing the data within the team. If we share the data out to everyone in the value stream, everyone gets a common view of reality. And this aids in communication and also demonstrates transparency, which can enhance trust. You'll need to make it easy to get to, though, or it won't likely get used. So one of the things that we can do is simplify the data to make sure that it's understandable and digestible by non-technical folks. Using things like our strategic groups functionality allows you to take multiple different devices or statistics and agglomerate them into a single value number. So I can see what percentage of this application is functional at this time, or what percentage of my remote sites are reporting any kind of a problem. And then putting that into a central place to view it using something like APIs or share pages, custom dashboards, or what we call unauthenticated access pages, which are pages where we can make the data visible without requiring any login credentials. Allows you to kind of customize the content to who's going to be viewing it, and then getting it at the appropriate level of technical detail. So one way to make this data self-service is to use what we call an information radiator. And that's just a system designed to display important status information in a public area, like a monitor on the wall of a hallway that everyone walks through. Your team can display metrics using our custom dashboard functionality to share useful data with all the other teams, like response time, remote site status, application velocity, system status, even current incidents or scheduled maintenance. And this will help to keep all of the teams in sync. If the network team knows about the server issues, for example, you might save some troubleshooting time if an issue gets escalated to the wrong team, or if it gets reported to multiple teams. Using information radiators also allows you to actively demonstrate core values, specifically that the team has nothing to hide from visitors, customers, stakeholders, etc., and that the team has nothing to hide from itself, that it acknowledges and confronts the problems as they occur. We also say you should monitor from where the users are. And this should be an obvious point, that the less direct control you have over the infrastructure, the more important it is to manage as high up the stack as possible. So that means monitoring application performance directly, just like a user would. OmniCenter integrates a network of remote reflector systems that allow your OmniCenter to monitor public-facing sites from all around the world, even if your OmniCenter is on-premise. Netreo provides a network of these for public-facing applications. You can also deploy remote collectors in as many locations as you like, while keeping a single centralized view of the entire enterprise. So I can deploy multiple remote collectors either in my private clouds or in my public clouds, or at my remote locations, so I can monitor how long it takes to get from a specific remote location to load and execute a specific application at my headquarters site, for example, or from a cloud provider if that's where it's hosted. These are designed to be really easy to configure and fully integrated into the application monitoring in OmniCenter. So it's literally as simple as setting up the application monitor and selecting where it will run from, whether it's locally or remotely on one of our public reflectors, or whether it's on one of your private reflectors that you've set up specifically to benchmark your applications with. And it allows you to run from multiple locations simultaneously, so you can isolate when problems are happening from a specific remote location, or from multiple remote locations, or from only the networks in Asia or only the networks in Europe, for example. And either way, your OmniCenter can be on-premise, or you can move it to a public or private cloud. So this lets you get deep application visibility no matter where it's running from or what infrastructure it's running over. And this is especially important if you're cloud hosting applications using direct internet access from your SD-WAN sites. So integrating the data across the enterprise is kind of a key in getting successful implementations. And this has been a primary goal of OmniCenter since the beginning. By integrating application level and system level metrics into a single user interface with consolidated reporting, you're enabling the system to detect correlations and the operators to better find the cause of problems without having to go on a scavenger hunt through multiple systems looking for issues. This is one of the key issues with SD-WAN providers who are trying to force users into their own private cloud dashboards, is it removes the ability to do easy correlation, it removes the ability to do single pane of glass views, and it increases the admin and the training burden that's involved. Now, let's look at some of the factors you should consider when you're selecting a vendor for SD-WAN migration. So you should always look at how long the vendor has been delivering virtual CPE and SD-WAN solutions. Do they have a proven track record? Is their technology developed in-house, or are they buying technology from someone else? And if so, who? And then how do they support that? With the explosion of SD-WAN providers, this can be a real concern for a mission-critical enterprise, because you don't want a vendor who's just brought their minimum viable product to market, and you don't want to do their beta testing for them at your own expense. So look for third-party validation. Most vendors will be able to come up with a few reference customers or a success story, but there's no replacement for a history of success. Ask about their SLA guarantee, because SLA and outage response times are very important metrics, and most private WAN technologies have been greater than 99.9% for a long time. But in an SD-WAN environment, you're dealing with a lot more potential variables. You've got small town ISPs, internet routing issues, and even things like DNS outages might affect the network. So make sure you know how your vendor handles these issues and what their redundancy plan is. What about the management and configuration portal? Can they show you uptime metrics with real data for that? Also remember that what your recourse is in that SLA. So if they don't meet their SLAs, what are they putting on the line with that guarantee? Because in many cases, you'll find there's no actual money behind the guarantee, or so little that it won't matter. If they're crediting back, 5% of one day's charges per site that's down for a day, that doesn't really make up for the fact that your enterprise is now offline. So find out about that when you're selecting a vendor. You should also look into how they support CPE failure, because even with a virtual CPE, it might crash, there might be a software problem, the hosting system it's on might have a problem, and some WAN vendors have a highly outsourced support model, and that might make it hard to get support for failed CPE. So find out if their support is based in your time zone, and if not, what their around-the-clock strategy is and how that works, and how long it takes to get replacement equipment if you're using hardware. Also, if it's virtual, find out who's supposed to troubleshoot that platform. You don't want to get in a finger pointing contest where they're saying, call VMware because it's a virtual CPE and we can't support something going on it. Find out how their support handles those kind of situations. You should also consider the difficulty of migrating away. So if your vendor selection doesn't work out, how hard is it to move over? Did you replace all their CPE? So you've got, all of your edge routers are now decommissioned and you've got CPE that belongs to the WAN vendor. How long is it going to take you to migrate that out? If they own and control those, you have to factor that into the decision and based on their track record of success and what their SLA guarantees are, kind of evaluate your risk based on those criteria. So a few things that we say are useful tips for making the migration a success. The first one is proof of concept. These are almost mandatory for a successful migration in an SD-WAN environment, because an isolated POC with a first site will help you make sure that all the configuration options are well considered. So the pilot site also provides an opportunity to make sure any unforeseen application or performance issues are resolved before a larger scale deployment. You should also give some thought to your QoS configuration. A well-executed QoS in SD-WAN can be transformative for a business process. So an example would be, with the right QoS settings, I might be able to do incremental backups throughout the workday in a low priority queue without affecting the critical traffic instead of batching them all to run overnight. And that approach means that a failure doesn't revert an entire day's worth of data. So that can be a massive improvement in my failover strategies, just based on getting the right QoS configured in SD-WAN. And testing in the environment will probably lead you to think of several other application examples like that you might be able to take advantage of. Your proof of concept is also the perfect opportunity to test the vendor's APIs. Some vendors claim more API capabilities than they can currently deliver. We've seen several SD-WAN vendors whose API development has lagged significantly behind their software capabilities, and that can lead to blind spots. Remember that a lot of vendors haven't been doing this in the real world very long at this point. So make sure you understand exactly what data they can and cannot provide to the management platform and how that data is provided. A JSON or a SOAP API is probably very easy to integrate, but scraping data off a web page is definitely not. So if they're giving you the data through an API, find out what kind of API. And if they're pushing that data, directly to the management platform, find out how they're doing that. Are they using a standard protocol like NetFlow or IPFix? And is it proprietary? Or do you have to open ports in your firewalls to get that data into your management system? These are all things that you should be thinking about. A lot of vendors would much rather just have you use their portal for everything because it makes their life simple. But being forced to use a vendor portal like this will create an information silo, and that's going to hurt your mean time to repair and will have a serious impact on your command center, capacity planning, and possibly even reporting capabilities. It can also create a lot of admin load when you have to set up new alerts or monitors or generate new reports. We've even seen some SD-WAN vendors who rate limit how much data you can collect from their API. That's going to severely limit their scalability. It may mean you lose centralized visibility or you make unacceptable delays in status changes. So a POC gives you the perfect chance to test this out. Also, you should deploy in parallel if possible. You may be able to deploy and test the entire SD-WAN before a cutover. So running in parallel allows you to basically keep the existing infrastructure in place until the actual change. So this can greatly reduce migration risk and give you a quick fallback in the event of unforeseen issues. But do be cautious about the potential costs of running parallel infrastructure for too long. One really common issue we see in these migrations is unfunded support requirements. So the reality is that migrating to SD-WAN means you're going to see an increase in the number of support tickets you have to deal with. It's really easy to underestimate or ignore the complexity of moving to internet-based connectivity, and this is certainly something most SD-WAN vendors are very keen to downplay. But if you think about it logically, SD-WAN makes your infrastructure more dependent on the internet, and increasing the number and type of internet connections is going to cause new issues. Dealing with small town ISPs, BGP issues, regional internet outages, even suboptimal routing are all things that might create additional load on your support team. So make sure you've thought through and budgeted for any new staff that you're going to need to handle that. You should also use this phase to evaluate the security implications if you're going to be using direct internet access. So enabling access directly from the remote locations will dramatically improve response times for cloud-hosted applications, but it can also make managing your security policy very difficult. So that can create additional admin load and might have other implications as well, as far as who's going to manage the firewalls, how do you handle firewall change requests, how long does it take to get those completed, things like that. You should also consider the impact on your alerting policy. So moving to SD-WAN is going to impact your alerting policy and response. Once the WAN is fully software-based, troubleshooting procedures, escalation, and even who the alerts go to might need to change. So you should plan this out in advance before it becomes a surprise. SD-WAN is almost certainly going to drive a requirement for additional training for frontline and command center staff. So at a minimum, they're going to need to know what to do when a remote site drops offline, like who to contact and how to get SD-WAN support. Because that's going to be different than if you're running a private network or even an outsourced network to a vendor. They need to know how to escalate those issues. You also should consider if it's possible to be able to identify CPE failure versus path failure. So SD-WAN vendors like to talk about how SD-WAN makes path failure impossible, but like everything Murphy touches, it's going to happen anyway. So you should be prepared for how to deal with it. If your SD-WAN vendor isn't outsourcing the path support, make sure you've got a good database or documentation system like the one built into OmniCenter to keep track of how to contact local ISPs and circuit providers, support information for the hardware CPE portion. There's always going to be some kind of router or edge device involved. Who do you call for support on that? Are there separate contracts required? All of that data needs to be kept someplace central. OmniCenter's documentation feature provides a great way to do that. You can integrate it directly into the alert messages that go out. But make sure you've got something defined for your frontline help desk staff to avoid creating problems there. Now, our philosophy for alerting has always been to reserve alerts for actionable items only, things you're going to immediately respond to. Because if you're not going to respond to an alert when you get it, why would you want to send it? If you overload the staff with alerts, it's just going to make them start filtering or ignoring the alerts. And if you start doing that, it's guaranteed sooner or later, someone's going to ignore the wrong alert and you're going to have a major problem on your hands. So if it's something that doesn't require an immediate response, you're probably better off relying on things like a scheduled report at the end of the day or week to stay aware of the issues without getting woken up in the middle of the night. I mean, imagine getting an email every morning that shows all the sites that showed higher than normal latency or bandwidth the previous day, things you might want to keep an eye on, but you're not going to get up in the middle of the night to fix. It's really easy to automate those reports in OmniCenter. With just a couple of clicks, nothing will get missed, but you also won't have your inbox or phone blowing up all day. You get to sleep through the night. So whenever possible, to use a report to replace an alarm, you're making yourself a lot more proactive and a lot less reactive in those cases. As always, if you have any questions, please feel free to reach out to us at info@netreo.com or to Netreo support. Thank you much for your time, and we hope to see you at another webinar soon. Thanks, everyone. Have a great day.